Hello. Hello. Um, right. Uh, Today we are likely to have quite a short session, just to warn you, mainly because for those of you that came on Saturday and Sunday, I think everybody in Key Stage 3 had the same homework. And so it means that there's just less to worry about, I suppose. Um, can we go through the year 7 booklet? Questions towards the end. Any specific questions? I mean, what I can do, mainly because everybody's got the same thing here, I could pretty much do the whole booklet, and I'm happy to do that for today, to reward those of you that are here. Um, I basically could just do the whole thing, and I think that will be useful for you regardless. And just to be clear, everybody in Key Stage 3, whether you're in year 7, 8, or 9, had the same homework booklet. So even if yours says booklet 1, which it might do, I can't remember. If not, it doesn't really make a difference. The point is, they're all the same. So all of these questions, I've got a feeling year 10 might have had the same one as well this week. Just because it's a fairly easy topic, it's just an important topic. So we tried to do it again over the weekend a little bit. So I would have thought most people found it quite straightforward. Right. I think I'll do that then. No, that's not zooming in. Oh, there we go. Right, yeah. Um, I think I will just go through this booklet from scratch, start to finish, talk about anything else that may be of interest. And then that'll be it in terms of today's session, and then I'll do the key stage 4 one afterwards. So I think I will just go through this booklet fully. If you do have any questions, please shout or type in capital letters. Um, right, expand the following. When we are expanding brackets, we multiply everything outside the bracket by everything inside the bracket. So 7 times 2x is 14x. That's what happens when you multiply numbers with numbers and letters. You just multiply the numbers together. And you also have to times the 7 by this 7, and that will give you plus 49. That is the answer to that first question. Right, then, this bit is slightly harder. So factorizing is harder than expanding, even though they are exact opposites of each other. So in expanding, we are effectively getting rid of the brackets. That's what we did here. And in factorizing, we are including some brackets. So we're going from something that doesn't have any brackets to something that will have some brackets. That's what factorizing basically is. And what we have to do when we factorize something is we need to first look at the numbers and decide what is the highest common factor. You may remember if you were in Key Stage 2 at some point, which you were, of doing something called highest common factor and these kind of things. It's about knowing your times tables really well. In this case, the highest common factor of 3 and 12 should be fairly obvious because it is a number that goes into both 3 and 12 that's as big as possible, and that would be 3. So we put that number outside the brackets. Another example will probably have some letters as well, but we'll come to that as we do it. Then what you put inside the brackets is whatever you multiply this by to get back to that, in this case, y, and whatever you multiply this by to get back to that, in this case, 4, 3y, and you can check these. This is the great thing about factorizing, is that if you now do what we did in this first question and expand it, 3 times y is 3y, 3 times 4 is 12, you should get back to here, and that proves that you have done it correctly. Expand this. 5a times a. When you multiply letters together, you've got to remember to put a little squared on the letter. So a times a is a squared, and the 5 is just there. And then the 5a is also being times by this 6, and 5 times 6 is 30. You have to put a minus here because there's a minus there, and the a is still stuck to it. So it's 5a squared take away 30a. Just to be clear, to anybody, if any of you have just joined, that this is the homework that everybody in Key Stage 3, 7, 8, and 9 will have had this week. Now, you probably didn't do much of this in the lesson, but you did do a lesson on this for those of you that were with us at the beginning of September. Sorry, at the end of September, because the very first maths lesson that we do is about this kind of topic to do with solving equations. I'll do this question. It's not the easiest, but I will do it. When you see numbers and brackets, most of the time, see what the questions are. You weren't here. Okay, I apologize. You are here now. So, the thing with these numbers and brackets is that you most of the time will expand the brackets out. In this case, you don't actually have to do it, but I will do it. I'll show you two ways to do this question in case anybody is interested. If I expand the bracket, I do 4 times b, 4 times 2, and have equals 24 after it. To solve something, what we're trying to do is work out what the letter is. And you might be able to tell in this case, because it's not actually that difficult to tell what the answer is. But if you wanted the full-on explanation, what you're doing is you're trying to get this letter by itself somewhere. The way you're going to do that is by first taking away 8. So what you need to do is try to get rid of this plus 8. You get rid of it by taking it away. 24 take away 8 is 16. And then what you do is you divide by 4, because what this is 4 times something, but we want the something on its own. So you move the 4 and you divide it, and 16 divided by 4 is 4. That is the answer to this question. Another way to do this, for those of you who are a bit more quick perhaps with this, what you could do instead here, if I just write the question out here, instead of expanding the brackets, you can realize that we are timesing it by 4 here. So we can actually move the 4 first by dividing it. 24 divided by 4 is 6. And then you get b add 2 is 6. And then b is 6 take away 2, which is 4. So I'm just doing a longer way to do that. But that really wasn't the topic we were doing today. Factorize fully. So with this kind of question, the first thing to do is find the highest common factor of 12 and 8. What is the highest number that goes into both 12 and 8? That number would be 4. Okay, remember it's the highest we're looking for. So whilst 2 is a factor of 12 and 8 as well, it is not the highest common factor. Correct. And so we put 4 outside. Oh, there's something else we can put outside. That's the numbers. Then we look at the letters. Okay, and this can get quite complicated to explain. But when you have letters more than once here, okay, you can take out the letter as well. Now, in this case, what you do is you look at M is correct. It sometimes gets problematic if there are lots and lots of big numbers on these, okay? In this case, there's like a 1 there. Remember, if there's no number on a letter, there's a power 1 on it. What you can do is you can always take out the fewer that there are. So if you think about it, there's 1 here and 2 there. You can take out the smaller number, so you can take out M in this case, or one of the M's. 4M, yes. 3 is correct. So now what we need to do from here is just put in the brackets what gets us back to here. 4M times 3 is 12M, so that gets you back to there. And then for the 8, 4 times 2 gives me 8, so I can put that there. But I also need another M, because I took one of them out, but there's 2 of them in total there. So that becomes the answer to that. Solve the following. I'll do this quickly, these solving ones. I'm not really interested in the solving questions. But if you expand the brackets, it's 3n take away 15 equals 27. And then you're going to add the 15. If you add the 15 to 27, you get 42. And then you divide by 3. And 42 divided by 3 is 14. And that becomes the answer to that question. There was, again, a quicker way to do that. You could have divided by 3 to get 9 and then added the 5. That would have given you 14. It's probably giving me answers. Yes, n equals 14. Excellent. Expand the following. 8 times 3s is 24s. And then 8 times minus 2 is minus 16. We have expanded. Factorize the following. Good. Minus 16. Yes, good. Excellent. Right, the factorize. The Biggest or highest common factor of these two numbers is 4. Okay, it is 4. We now need to put something here to get us back to 4t, which is another t, so 4t. And then we need another number to get us back to 20 when you times by 4, and that would be 5. Essentially, what you're doing is you're doing this number divided by that number and putting it over here, this number divided by that number and putting it here. That is done. I have done questions 1 and 2. So, yeah, done those. And also, it's the same booklet for everybody, just to be clear. So, whether you're in year 7 or not, this is the booklet, and I'm just going through the whole thing. So, I have been through the first couple. You will have a recording, of course, of this available on your um, on the YouTube. I can promise you it will end up there. So, you can find it later should you need to. All right. Okay. Sorry. Okay. Factorize fully. So, a bit more of a harder factorizing question here. We will first look at the numbers 5 and 15, and you're going to find the highest common factor of 5 and 15, which is 5. And then you're going to open brackets up. But then there's more. So what you have to do now is look at the letters here as well. We've got 2 a's here, or a squared, and 1 there. What you can do is take out the smaller amount. So if there's 2 here and 1 here, you can take out one of them because 1 is smaller than 2. With the b's, it's the same thing. We've got 1 b on the left and 2 b's on the right, or b squared. We can take out one of them. So that comes out. Once you've taken those out, now what goes in the brackets is whatever gets you back to these things here. So if we look at this, the 5 has already come out. Of these 2 a's, one of them has come out, so one of them needs to be in the bracket. And of the b, it's already come out, so there's nothing else to do in the brackets. For the other one, for the 15, I need a 3 to get us back to 15, because 3 times 5 is 15. That a has already come out, so don't need to do anything. The b's, there's 2 of them here, and one of them has come out, so the other one needs to stay there. And therefore it is 5ab brackets a plus 3b. Excellent. Solve this question. Again, what I'm going to do it the longer way, which is to expand the brackets out. 6 times c is 6c. 6 times minus 8 is minus 48. Okay, that's going to be a big number. Okay, then I have to add this 48 to this 42 to get 90. And then I'm going to divide by 6, and 90 divided by 6 is 15. Good. This one, the first hour is, or the up to 8 o'clock is for key stage 3. And then I do the key stage 4 stuff from 8 o'clock. Although, to be fair, if you are in year 10, not sure what year you're in, but year 10, then this is the same booklet, I think, that year 10 got as well. So if you're here, then you could sort of get it done early. Factorize 18x plus 24. Oh, God. Okay, answering it. Right. The highest common factor of 18 and 24 is 6. And then we need to put something in the bracket. There's no letter in both, right? So you can't take a letter out here. So we need the 3 to get you back to 18, and we need the x to get you back to 18x. And then over here, we need a 4 to get you back to 24. So 6 brackets 24 is correct. Expand the following. 3 times 2y is 6y, and 3 times minus 4 is minus 12. That's done. 6y minus 12, very good. Expand the following. When you multiply 2 letters by themselves, you need to put a little 2 there to recognize that it's p squared. And then the p times the minus 3 is minus 3p. That is the expanding done. Factorize 16q plus 8. Highest common factor of 16 and 8 is 8. There's no letters to bring out. P squared 3p. I need to get back to 16, so I'm going to put a 2 there, and then a q there. And then I'm going to put 8 times something is 8, so I'm going to put a 1 there. Correct. Very good. Factorize fully, slightly harder. Highest common factor of 6 and 4 is 2. But then we need to look at the letters as well, because I've got an x there and 2 x's here. So I can bring out one of those. You always bring out the fewer. I cannot bring out a y because there's no y in both of them, so therefore we can't bring that out. And then we make this work. So to get back to the 6, we need a 3. And we've only got one x here. We need two of them, so I'm going to put another one there. To get back to the 4, I'm going to put a 2 here. 2 times 2 is 4. The x has come out already, and then we've got the y. Okay, done. Right, this one is going to have a decimal as the answer, or a fraction, I think. If you expand the brackets here, you get 2w, take away 8 equals 13. You're then going to add the 8 over to get 21. And then we're going to divide by 2. Now, I want to leave the answer like that, but it is 10 and a half, should you be interested. But I'm going to leave it like that. Factorize x squared, take away 9x. So this time there's no numbers in both of them, but there's an x in both of them. So let's take it out. How do we get back to x squared? We need to times x by itself. So x. How do we get back to 9x? We need to times x by 9. And of course, somebody has written x minus 9. Of course, that is correct. Okay, expand this. 6 times 5y is 30y. 6 times 1 is 6. We have expanded. Remember, factorizing is the opposite of expanding. Okay, so we are just doing both things in most of these questions. We're just sort of, in one, we're expanding, where we're removing the brackets, and the other, we are factorizing, where we're including the brackets. And God, right. Expand this, and we get 3 times 5x, which is 15x, and 3 times minus 8, which is minus 24. I'm just firing in the answers here. Okay, factorize 18y plus 15. The highest common factor of 18 and 15 is, by my reckoning, 3. There is nothing else I can put outside the brackets because there are no other letters. So we just need to get us back to where we began. So I'm going to put a 6 there to get us back to 18, but I also need the y here. And then I need a number that gets me back to 15, which is 5, because 3 times 5 is 15. Yes. Expand the following. 7 times 2h is 14h. 7 times minus 3 is minus 21. We've done it. And then a bit longer. Expand and simplify. Right. Be careful with this. 4 times g is 4g. 4 times 5 is 20. 3 times g, we add it on, is 3g. And 3 times minus 2, be careful, is minus 6. And then you've got 4g add 3g, like the mobile phone stuff. 7g is what that adds up to. And then 20 take away 6 is positive 14. A lot of people mess up with these minuses because they confuse it with a different topic. But that is what it is. Okay. Factorize fully 7xy plus 21x. We will take the highest common factor of 7 and 21, which is 7. Okay. Oh, there's more. We also need to look at the letters. There is an X in this one, and there is an X in this one, so we can take it out. There is no Y in both of them, so we cannot take it out. It has to be common. What do we need to get this back to where we were? So we just need a Y, don't we? Incredible. Because that makes 7xy. Lost track of the answers now. I will go back on 11 in just a moment. And then we need a number that multiplies by 7x to get to 21x, which is just 3, right? There is 11. If you need any questions, please let me know. Okay, solve the following equation. Two ways of doing it. I'll do both ways again this time. Expand the brackets, then you get 6p plus 18 equals 42. You would then subtract 18 because we're trying to get rid of this. 42 take away 18 is 24. Okay. Um, and then 20, no, something's wrong. No, it isn't. And then 24 divided by 6 is 4. Alternatively, what you could have done is you could have divided by 6 at the beginning, because 42 divided by 6 is 7. Then you'll get p plus 3 equals 7. And p is 7 take away 3. So two ways of getting to the same answer. P equals 4 is correct. We nearly finished. 13. Expand A plus B. A times A is A squared, and A times B, when you're multiplying different letters together, just stick them together. And that's all we're after. It's nice colour, that, isn't it? Factorize 15y take away 6. The highest common factor of 15 and 6 is 3. Okay, so the biggest number that goes into both of those numbers. To get back to the 15, we need a 5, and we need the y as well. To get back to the 6, we need a 2, and put a minus in the middle. God, we're writing all of the answers, are we? I've lost track of where we are now. Okay. Expand this one. Okay. 27xy minus 76. Yeah, yes, it is. 9x times 3y is 27xy. Remember, if you just time the numbers together, but then any different letters stick together. If the letters are the same, then you put squares and cubes and things. 9 times 8 is 72, and that x has to stay on it, so it's 27xy minus 72x. Expand and simplify. Long again. 7 times t is 7t. 7 times minus 4 is minus 28. Plus 5 times t is 5t. And 5 times minus 2 is minus 10. And then we need to simplify. 7t add 5t is 12t. And to be very careful with this, do not make a mistake. Minus 28 minus 10 is minus 38. Not positive, because two negatives make a positive and all that stuff that you learn sometimes. In this case, you are just doing the question, minus 28, take away 10, which is minus 38. Okay. Factorize fully, the highest common factor of 30 and 12 is, by my reckoning, 6. There are 3 x's in here and 1 in here. We can take out the smaller amount, so 1. We then need to put in here what gets us back to where we were. 6 times 5 gets you back to 30, and x times x squared gets you to x cubed. That's important that you need 2 of them there to get back to the 3 that we had. And then to get from 6x to 12x, we need to times by 2. And that's it. Solve. Are we nearly done? Wow, there's so many questions in here. Okay. Solve. 5 times f minus 2 equals 22. So expand the brackets. 5f take away 10 equals 22. Add 10 to get 22, add 10, which is 32. And then divide by 5. And you can leave it as a fraction. I know people seem to get stressed out over that. But it is just it's fine to leave your answer as a fraction. Expand the following. X times 8x is 8x squared. X times 1 is x. Done. Factorize 18 plus 63. The highest common factor of 18 and 63, I think, is 9. And then we need to get back to the 18, so I'll put a 2. 9 times 2 is 18. We need to get back to the 63. 9 times 7 is 63. And we need the y stuck onto here, so that works. Expand. So 2 times 4 is 8. Then with the x's, when you're multiplying x squared by another x, we've now got an x cubed, because there's 3 of them, effectively. We've got a load of answers again. Yeah, we have. Minus 2 times 9 is 18, and the x squared gets stuck on. 8x cubed minus 8. Very good. Expand and simplify. 6 times y is 6y plus 6 times 3, which is 18. Be very careful with this one. This could be where people go wrong, because this number is a minus 5. Minus 5 times y is minus 5y. But minus 5 times minus 4 is plus 20. And then you have 6y take away 5y, which is 1y. 18 plus 20 is 38. Okay. Factorize fully. 30a squared plus 40ab. The highest common factor of 30 and 40 is 10. Then we look at the letters. We've got two a's over here and one a over here. The smaller amount will come out. And then the b's don't come out because it needs to be in both of them. We need 3 to get back to the 30, and we need another a to get back to this a squared. Over here, we need a 4 so that we can get back to the 40, and we need the b to be there so that we can get back there. Are there any questions? What was 17b? That was my explanation for 17b. Um, Question 12, I will show you again. I have been through the whole booklet, actually. So, just to be clear, everybody got the same booklet. Although, actually, what day did you come? Ah, this is going to be complicated. E- Um, okay. There'll be some of the maths from last week that people are asking as well, which I'll need to just go over in a second. But I can see the person who's asked that. Year 8, question 12. This is not the same booklet because you did a different one because you came on Thursday. So I'll need to get back to that, which I'll show you in a moment. But let me finish this and I'll go back to that. Um, okay, so solve 3g plus 9 is 21. Um, 3g plus 27 equals 21. 3g equals, oh God, it's negative, minus 6. And then I don't know why I've changed color. Apologies. G equals minus 2, I think is the answer to that question. Okay. 19. N times 5n is 5n squared. I'm nearly finished with this one, so I'll be going back to that question that you have asked about year 8, question 12 in just a moment. I'm not going to go back now to question 15 because I have done it, so you can see it on the recording of it later. 5n squared. N times 1 is n. 5n squared plus n is the answer to that. Factorize 18m plus mn. If I take out the m, because that's the only thing I can take out, I'm going to be left with 18, because that gets me back to 18m, plus, what do I need here? Just an n. So that is the answer to that. Nearly done. Bit harder, this one. 3 times 7 is 21. The x's, x times x squared gives me x with a little 3 on it, because there's 3 of them. Minus, and then this 3 times by all of this, and it all just gets stuck together. So that is the answer. Yes, I know. So it's the days that you come. So any questions that you have from the biology booklet, please just ask. It is fine. I'll get to it. Just make it clear which one you're asking. So at the moment, I'm just going through this so that everybody who did maths, because they came on a Saturday and a Sunday, are done. And then I can talk about anything else. It's very confusing at the end of the month because depending on what day of the week you come, you do a different thing. So it's very complicated. 3 times 6y is 18y. 3 times 5 is 15. Minus 2 times 4y is minus 8y. Minus 2 times minus 1 is plus 2. And then 18 take away 8 is 10. And 15 add 2 is 17. So that should be the answer to that question. 10y plus 17. And check these against somebody else's work. Um, let me get through the end of this, then I'll just let me finish this, and I'll show you question 2 and 3 that I did earlier. So highest common factor of 18 and 30 is 6, I believe. Oh, and then this is probably the hardest question so far. We need to look at these and figure out what to take out. Now, because we've got two A's there and one there, we can take one of them out. We've got one B there and one B there, so we can take it out. We've got a C there and two C's there, we can take one of them out. We can always take out the smaller number. How do we get back to 18? We put a 3 there. How many more A's do we need to get from here to there? We need one more. Do we need any more B's? No, because we've already just got one of them. Do we need any more C's? No. Done. Plus, how do we get from 6 to 30? We need a 5 times it by. We have already got we've only got one A there and we've already got it there, so done. We've already got a B there, done. But there's two C's here and only one there, so we need another one in the brackets. So it becomes 6A, B, C, 3A plus 5C. And finally, expand and simplify. 4 times 2y is 8y. 4 times minus 7 is minus 28. Minus 3 times 5y is minus 15y. And minus 3 times minus 3 is plus 9. 8 take away 15 is minus 7. Minus 28 add 9 is minus 19. That's a really tricky question, that last one. Um, just because of all the minuses. Right, so question 2 and 3, somebody asked me that I need to move on. Um, is there a break for term 1? What does that mean? Um, 2 and 3 are on the screen at the moment. Um, you can have a quick look at them. There's question 2 and 3. I'll give you another 10 seconds to look at them, and then I'll show question 15. Then I need to move on to people that have got any other questions. No, the answer is there is no break. Sorry to say. Your lessons, especially if you're on the weekend, are on as normal. The only tricky one is if your lesson falls on a Thursday, in which case I've already been in touch with your parents about shifting it, mainly because Christmas Day and New Year's Day are on a Thursday, and nobody really wants to come then. But it doesn't affect the weekends. Um, right, and then somebody asked me question 15. Right, that was question 15. Right, and then um, go on 4, please. Right, so anybody who has questions on, if anybody attends on a weekend now, Saturday and Sunday, and you did the expanding and factorizing stuff, I have been through the entire booklet from question 1 to the end. You are able to watch a recording of it. I now need to just move on because I have done the whole booklet and it is available to you to watch. Um, I need to just answer any question anybody else has from elsewhere. So, year 8, question 12. Amelia, you came on a Thursday, so you must have done. I'm trying to work out which booklet you're on. Um, it'll be fractions, decimals, and percentages, won't it? Um, yeah. So I want to revert back to that, which must be there. And you're asking for question number 8, which must be this one. Okay. I think that's the question you're asking me, but please correct me if I'm wrong. And if anybody has questions on the digestion booklet, then please tell me. But that should only be anybody who comes on a Monday, probably. Monday, Tuesday. I think we just started it on Monday. Um, so yeah, it's quite complicated at the end of the month because everybody does different things. But as of next week, we should be sort of in sync again. 20% of a number is 64. Now, it's quite hard, this question, but I'll tell you how you can do it. 20% of a number, we don't know what the number is 64. Now, 20% is the same as 1/5. So now I'm saying that 1/5 of some number is 64. We should be able to figure out what that number is because what we can do is times 64 by 5. As in other words, my number is 5 times smaller than, or 64 is 5 times smaller than my number. So I surely can work out what the number is by timesing this by 5. 64 times 5 I can do in my head is 320. So that means the number we started with here was actually 320. And the question is, what is 50% of that number? 50% of 320 is half of 320, which is 160. Okay, that was that. 1B, 4A, part 2. Again, you need to be clear about what booklet you're talking about for that question. 1B, 4A, part 2. If it's the expanding and factorizing booklet, then that has all been done. And you can watch it back should you wish. But 1B, 4A, part 1. I need to know which booklet you are referring to. Biology, sure. Happy to do that. Right, so I appreciate this won't affect many people, but you will be doing some digestion this weekend. um, in terms of learning it, not just eating food. Um, which booklet number is it? The enzymes and digestion one? Is it booklet one? It must be booklet one, right? Yes, it must be. Yeah, thought so. Thought so. I know who you are. Um, so for those of you who are attending the weekend, you will be doing this over the weekend, and it will be your booklet. I want to change this process next year, but we will see. So your 1B, right, let's have a look. Why do molecules of starch, protein, and fat need to be digested? The reason we digest anything is to make them smaller. Okay, so basically, they need to be digested because they're too large to be absorbed into the blood. That's the reason for it. And then 4A part 2. The villi absorbs the product of digestion by. It is called diffusion, which is where if I've got loads of little food stuff here, then it goes into these villi. The villi are in your small intestine. It's where the blood is and like absorbs everything. They move from a high to a low concentration into your blood. And that process of moving from a high to a low concentration is called diffusion. 1B for A part 2. Anybody got any more questions? That seems to be that's all I've got. Might do today's Wordle. No, I've done it. Never mind. Okay, so on the basis that nobody has any more questions on either expanding and factorizing, which is what people did on Saturday, Sunday, the fractions, decimals, and percentages that some people did on, God, I've lost track of days now, Thursday, um, or Friday, or on the digestion if you attend on a Monday, 19 and 20. I've done that. Isn't that the, so are you asking me for the expanding and factorizing? Okay, I'll show you it, but I mean, I've done it. There you go. 19 and 20. There you go. There you go. That is 19 and 20 shown. Okay. Um, I am not going to show you anymore because I get the feeling that you are writing the answers in as we do this. Um, okay, fine. I think that's it for you guys. I will return for another hour in 7 minutes in case anybody from year 10 or year 11 has any questions on this booklet, which you shouldn't have really if you're in year 10, and more importantly, the year 11 did something called proof, which is challenging or can be challenging. So hopefully I'll have some questions on it. Right, I'll be back in a short while. Oh, 8B booklet 3. Which is that? You need to tell me which booklet that is. Are you asking me for the maths expanding and factorizing? I think you are. Is it the expanding and factorizing maths? Okay, last one, 8B is here. Right, I'm going to go and I will return in 5 minutes. Right. Hello. Depending on what day of the week you attend, there will be some slightly complicated things going on here, um, as is the case for the previous few weeks. So, if you come on a Thursday or a Friday, you will have been doing some maths. Um, and if you come on a Saturday, well, sorry, you'll have done some different maths to everybody else. So you'll have done some sine rule, cosine rule, and surds and indices. If you come on the weekend, Saturday, Sunday, you'll have done some expanding and factorizing, quite easy stuff for year 10, and some proof stuff for year 11. So when you ask a question, if you ask a question, then please tell me which topic specifically. Proof, year 11. Yes, I'm probably going to do most of the proof stuff because it is a complicated topic, but that's why I would rather do it early in your year 11 career than late because it is quite a complicated thing. Um, 4, 6, 9, 10, 11, 12, 13, 14. That's basically the whole thing. But I will happily do that today. Are there any other questions, firstly, from any of the other things other than proof? Because I would rather, once I start it, just stick with that. And actually, if you did the expanding and factorizing that year 10s did at the weekend, then I would still stick around for the proof stuff because it kind of relies on you knowing expanding and factorizing a lot. Okay. It seems like so far, oh, 21A expanding. I think, well, see, the thing is, this booklet here, I just actually, in the last hour, I did the whole booklet because Key Stage 3 had the same thing basically this week because they just did. Um, so 21A looks like this. And that is the answer to it. So you have to look at the 18 and the 30 and realize that 6 is the highest common factor. So that comes out. Then you look at the A's, and there is one A in both of those terms, so that can come out. Um, there is a B in both of them, so that can come out. And there is a C in both of them, so that comes out as well. So we have 6A, B, C outside the bracket. And then what goes into the bracket is whatever you multiply by to return to the thing we started with. Someone's joined my personal meeting room, which is incorrect. Okay, no other questions then. In that case, I'm going to go on to the proof and focus on that. Right. So this topic of proof is particularly complicated. Now, I would have thought that quite a lot of these you may have done in the lesson, may have done, or maybe not. Maybe I've got that completely wrong. Um, yeah, maybe not. So let me go through the questions that have been specifically asked. If there are others, then you can tell me. But question 4 has been asked, which says, prove algebraically that the sum of these two is always a square number. So sum means add together. So I've got n brackets n plus 1, add another n plus 1. So what we generally do in this topic, which is why it helps if you're in year 10 and you did something about expanding and stuff, is that this kind of relies on you to be able to expand and factorize things. So if I expand this out, it is n squared plus n plus another n plus 1. This bit in the middle can factorize. Sorry, to simplify. N plus n is 2n. plus 1. Now, you may not have done much on quadratic equations, but if you're in year 11, then you should be comfortable with this, which is that this thing can factorize into two brackets. We have to find two numbers that multiply to give the 1 at the end and add to give the 2 in the middle. And those two numbers are 1 and 1. 1 add 1 is 2, and 1 times 1 is 1. Um, yes, the year 10 surds and indices booklet. I'm going to do it after this question. Um, n plus 1, n plus 1 is what that becomes. And then the crucial thing about this next bit is because we're trying to prove a square number, you need to realize that because it's the same bracket twice here, I can write it as that. That is a square number. A square number just means something that has been squared. And that is something that has been squared. And that's it. Right. So let me just go back to this one question that has been asked from Yeah, question 3, proof year 10. That doesn't quite make sense. Do you mean expanding? I'm quite confused about that question. Anyway, let me do this 8B of the year 10 surds and indices booklet first. Which is question 8B, which is this one here, is it not? Okay. Let me go through the whole thing. Right, really long this one, but I shall do it. Firstly, we have a bracket that's being squared. So, squaring a bracket means writing it twice. So I'm going to do that. Okay, then what we do is we multiply everything there by there. So I'm going to do this slowly. That is the square root of 36 if you do 6 times 6. Then you do 6 times 12 there, which is 72. Then you do another 12 times 6, which is 72. And then another 12 times 12, which is 144. At which point you can realize that this is 6. Square root of 36 is 6. Square root of 144 is 12. The square root of 72, now this is I'll do this over here, can be simplified to the square root of 36 times the square root of 2, because 36 times 2 is 72. And 36 square roots to 6. So this root 72 is 6 root 2, and this other 72 is also 6 root 2. And then you simplify the like terms. 6 add 12 is 18, and then 6 plus 6 is 12 root 2. That is the answer to the question. Right, so let me go back to proof. No, that's not it. Okay, 4, 6, 9. Right, 6. Once again, similar sort of question about the square number, and it's going to be almost identical as well to the previous question. In fact, it might be the same. So, sum of means this added to this. Expand these brackets out and you will get n squared plus 3n plus 2. Okay, I promise. And then if you simplify this, you're going to get n squared plus 4n plus 4. And this also factorizes to two brackets, and those two brackets are n plus 2, n plus 2. And how else can we write n plus 2, n plus 2? N plus 2 squared, which means that we have a square number. Okay, done. Right, what was else? You said question 3, proof. I mean, I assume that's this question, although you asked me expanding before that, so I'm assuming you're asking me this question. Prove that this is always a multiple of 12. Okay, I want to do this really fast, okay? Because what takes long with this question is correctly expanding these brackets out. But you should be able to expand a pair of brackets by writing them out twice and going through the process of expanding them, okay? Which is for that times that, all that stuff. It takes ages, but it is what it is. But there is a quick way to do these expanding squared brackets, which I'm going to do now. That is 9n squared plus 6n plus 1. And we're minusing 9n squared. Oh, just change this a bit. Minus 6n plus 1. Okay, you've got to be very careful here, as for those who I taught this weekend, I kept saying, be careful with these minuses, okay? Because what that does is it makes that a minus n squared at 9n squared. It makes that a plus 6n, and it makes that a minus 1. It is very easy to mess that up. 9n squared, take away 9n squared is nothing. 6n plus 6n is 12n, and 1 take away 1 is nothing, which means we finished with just 12n, and 12n is a multiple of 12. That's all we had to do. So really, most of this topic is expanding brackets and simplifying, which is kind of what everybody else did. Question 4, I've done. 6, 9, 10, 11. Let's see what 6 is. Did 6. 9. Prove algebraically that the sum of the squares of any two even positive integers. Jeez. Right, hopefully you did this in the lesson, which is you were told how we describe positive numbers in this kind of topic. Sorry, even numbers in this kind of topic. An even number is basically best written as 2 times something, because that makes it automatically an even number. And then what we need is any two even integers. So we need another one, right? The easiest way to get to another even number from one even number is to add 2 to it. That's another even number, right? That's an even number, no matter what n is, assuming n is a whole number, that is an even number, and that is another even number. It says the squares of two positive numbers. So I'm going to square that and square that. And then it says the sum. So I'm going to put a plus in the middle. And then again, we just need to expand correctly and simplify. 2n all squared is 4n squared. 2n plus 2 is 4n squared plus 8n plus 4. These two add up to give 8n squared. And we get this far. Now, how do you prove that this is a multiple of 4? Well, you just need to notice that, a bit like the factorizing that we just did, or that you attended, is that you can see that 4 is a factor of all of these numbers, of 8, 8, and 4. So take 4 out and just figure out what goes in the brackets, which is this. And then you have shown it is a multiple of 4, because that's what we mean. We're just looking for a 4 out to show that it's 4 times something, and that makes it a multiple of 4. 10, 11, 12, 13, 14. Okay, that's all of them. Okay, fine, I'll do it. Again, you should have done quite a lot. A lot of these should have been in your notes. I think we did this. But anyway, prove algebraically that the sum of the squares of any two odd positive integers is always even. Odd integers. So, the question is, go through why. I don't know what that means. Why didn't you do two brackets like question 4, quadratic? So for this one that we just did, good question. Why didn't we do two brackets? Because, firstly, I'm not sure what the two brackets are. That's the first point. But secondly, it is because the question is after a multiple of 4. And I've reached that by just taking this 4 out and stopping. Okay? Because that's it. The point is you're trying to do what the question is asking you to do. In this case, the question is asking you for a multiple of 4, and I've done it. The previous question was asking you for a square number. And so with this one, the only thing I mean, there was no number I could take out in the same way, but I could realize that if I factorize this, it's the same bracket twice, which gets me to the square. So it's really a case of what the question is asking you to do. Um, Yes, correct. You're trying to follow their answer, essentially, yeah. So the question is telling you what your end goal is, and you're trying to work towards that end goal. So it is a bit of a weird backwards kind of topic where you're trying to do something that, yeah, you're trying to work from the end backwards almost. But as I say, I wouldn't worry too much about the final point of this because the most of this topic, as you can see, is expanding brackets correctly and simplifying. So even if you got this far and you didn't know what to do, I mean, out of these 2 marks in this case, I think it would be worth more than that. But you got one of the marks anyway for correctly getting that far. So you see what I mean? It's not the end of the world. Right, what else? We're going basically the whole thing now, aren't we? Two odd positive integers. Right. Right. As we said earlier, and this should have been how your lesson began, really, on this topic. If you've done the topic on proof, um, that the beginning, that an even number this is how we write any even number. Any odd number is always an even number plus one. So we can use that as an odd number. That is definitely an odd number, no matter what number I put in as n. I could put in 4, and it'll give me 4 times 2 is 8, plus 1 is 9, which is odd. I could put in 3, it'll give me 3 times 2 is 6, plus 1 is 7, which is odd. That is definitely an odd number. But we need two odd numbers. So to get to another odd number, I'll just add another 2 to it. If I've got an odd number and I add 2 to it, I get another odd number, don't I? Right? So I could add 5 or I could add 7. It'll still give me more odd numbers. Um, the squares of them means that squared and that squared. The sum of means you add them together. So that's your setup for this question. And look, what are we trying to get to? We're trying to get to something that's always even. We're trying to prove evenness. The way you prove that something is even is by showing that it is a multiple of 2, just like this thing was here. So the end result, whatever we get, we want to basically hope that we can take 2 out as a factor and leave everything else inside the brackets. So if I expand this bracket quickly, it's going to be 4n squared plus 4n plus 1. If I expand this bracket quickly, it is 4n squared plus 12n plus 9. You'll get there. Okay. 4n squared plus another 4n squared is 8n squared. 4n plus 12n is 16n, and 1 plus 9 is 10. And because I've got all even numbers here, I can take 2 out as a factor. Because again, this is again going back to that earlier question. You can deal with this. When you say the last 2 questions, I presume you mean on the proof paper, but please tell me if not. Um, because we're trying to get to an even number, I'll just take 2 out and have 4n squared plus 8n plus 5 inside the brackets. So make sure you do that correctly. Obviously, yes, you want the 2 outside, but make sure everything inside is correct as well. Don't just vaguely put anything inside. Um, if they wanted odd, then hopefully we'll see an example of that, yes. But with odd, the idea of an odd is that you see if this had been a 9 at the end, and I had to show that this was odd, the best way to do it is to go, well, let's change the 9 to 8, add 1. Let's factorize the 2 out of there to show that this bit is even, and then have the plus 1 at the end. Best way to do that. And we might get a question on that in a second. I can't remember. Oh, maybe this one. Prove that the sum of the squares of any two consecutive integers, n, and this is not even or odd, so you can just use n. N is a number. But consecutive integers means the numbers that are next to each other. So I'm going to have one more than that to show that it's the consecutive number. It's one more than it. The sum of the squares, so we need to square them and sum them. So that's what we need to write down. Let's expand the second bracket to n squared plus 2n plus 1. Let's simplify the n squared, so 2n squared plus 2n plus 1. And then this is exactly the question that you just asked a moment ago. In this case, how do I show that this is always an odd number? Well, I'll need to show, and you're allowed to do this. I think sometimes people think that if you're factorizing, you've got to look at the whole thing. You don't. You can just look at the bits you want to look at. So we can look at those two. And out of those two, we can take a 2 out and leave myself with n squared plus n. I know that ordinarily, if you were fully factorizing this, you'd take the n out as well, but you don't need to because you're just trying to show an even number, and that is an even number. And then there's a plus 1 outside it. So there's an even number. Plus 1 makes it an odd number. But this is always an odd number. 12. Prove that the sum of the squares of two consecutive odd numbers is always 2 more than a multiple of 8. A mouthful. Consecutive odd numbers. Oh, another thing that I would do if you were seeing this kind of question. Whatever it says after the is, you may as well ignore for now because it's irrelevant until the end, as I've just showed. It's kind of irrelevant. So we need to prove that the sum of the squares of two consecutive odd numbers, firstly. So an odd number, as I said earlier, that can show an odd number because it's an even number plus 1. That is an odd number, definitely. A consecutive odd number has to be the one that's 2 more than that. Okay, so 2 more than this turns that into a 3. So these are consecutive odd numbers. We want the squares of the consecutive odd numbers. We want the sum of the squares of the consecutive odd numbers. So it's just going through each word there and gradually making sure that you have satisfied what it says every time. Can I do 2? I will do 2. Did I not do that earlier? Yeah, sure. It's really easy, number 2. I shall do it. Um, Sum of the squares of two consecutive odd numbers. And now all we need to do is expand all of this and simplify it, which again, it'll take you time, but I'll just do it quickly. Make sure you do it accurately and get the right answer. So 4n squared plus 4n plus 1 plus 4n squared plus 12n plus 9. Simplifies to 8n squared, 4n plus 12n is 16n, and 1 plus 9 is 10. Is this the same thing we got earlier? Very similar, isn't it? 8 times 12 yeah, okay, fine. Um, So before, it was actually the same thing, wasn't it? Before we were trying to show that this was always even, I think, and we managed to do that. So if it said always even, we would take the 2 out of this and that'd be done. But this time it's not always even. It's always 2 more than a multiple of 8. This is quite confusing, but I'll just tell you what to do for the time reasons. 2 more than a multiple of 8. What you have to do is change the 10 to 8 add 2. Then you look at this and take the 8 out. Now, that is, as you can see, hopefully, 2 more than a multiple of 8. That is a multiple of 8, because it's 8 times something, and then we're doing 2 more than it. And that's it. So remember, you can split numbers up. Like that 10, you can split up into whatever is convenient for you to deal with the question. In this case, it was convenient for me to change it to 8 plus 2, because then I could show that it was 2 more than a multiple of 8. I'll just go back to 2, because um, prove algebraically the sum of any 3 consecutive even integers. Right, an even integer, 2n, can be an even number. Consecutive means the ones after each other. So that's 1 more. Okay. So 2 more. Remember, you have to add 2 to an even number to get the next even number. And then the next even number after that will be 2 more than that again. So there'll be 2n plus 4. So that's an even number. That's the even number after it. That's the even number after that. Consecutive even integers. Sum, add them together. If you add together all the n's, you get 6n. Add together numbers, you get 6. Multiple of 6. Done. Okay, so you take the 6 out at the end to get that. Okay, I'm getting to 40. Oh. Right, question 13. Prove that the difference between the square... Oh, God. Okay. Prove that the difference between the squares of any two consecutive integers is equal to the sum of these integers. Okay. Consecutive integers. Okay. Let's use n as one of my numbers. Consecutive means the one after that. That's the one after that. Okay. The squares of two consecutive integers. So I need to square both of these. So I'll just write that below it. So the first, that is n squared, and that is n plus 1 squared. Okay. Um, and then it says the difference between them. So that's new, isn't it, compared to what we've done so far? The difference between these two numbers, not adding them together. So what I'm going to do is I'm going to take the bigger one, because that's obviously bigger, and subtract the other one. That's the difference between the squares of two consecutive integers. Let's work out what happens here if I do this. What do they mean by these? I mean, that is what they mean. I'll explain this in using real numbers in a moment, because it is quite interesting. But let me just finish this off. So that is a integer. That is the number after it. That's consecutive. Um, and then that's them squared. So that's the first one squared, the second one squared. The difference between them is this, because you'd minus them, essentially. If you expand the first bracket, you'll get n squared plus 2n plus 1. Okay. And that minus n squared is still there. The n squareds disappear, because n squared take away n squared is 0. And you're left with 2n plus 1. How does that prove It says prove that the difference between the squares of any two consecutive integers, which I've got here, is equal to the sum of these two integers. What are the two numbers I started with? What happens if you add them up? You end up with the same thing that I had here. So that's what it's asking you. I know it's a wordy thing, and it's like almost hard to get your head around what it's even saying. But it's saying that if I've got two consecutive numbers, let's say I was going to do 6 and 7, but I can't do that for obvious reasons. Um, 3 and 4. Okay. Um, let's say 3 and 4. Um, it says if you square them, okay, and you work out the difference between them. So let's just do that here. 3 and 4 are my numbers. If I square them, I get 9 and 16. If I find the difference between these two, which is 7, it is the same as if I'd added up those two numbers in the first place. Let's do that with two more numbers, just quickly. Um, I was confused at these. Okay. Yeah, I get it. Yeah, so that's the explanation for it. But let me just do one more example to prove. If I've got 10 and 11, right? If I square them, it's 100 and 121. If I subtract those two, I get 21, which happens to be the sum of the two numbers I started with. So the point is, I'm showing you with examples like 3 and 4 and 10 and 11. If you keep going, it'll work with every pair of consecutive numbers. Um, I'm showing you with some examples, but the idea of a proof is that you do it without using specific numbers. You see, I used general algebraic ends and stuff to do that, and I still proved it to be true by showing that what I end up with is the same as what I would have ended up with if I had added those two together in the first place. So that's what this proof concept is all about. How did you go from 11 to 100? You times it by itself. Yeah, squaring a number, 11 squared. So the whole point of this is the squares. That means you square them. So 11 times, you times them by itself. So, and that's what we did here. We had n, and I times it by itself, which is what n squared is. And I had n plus 1, and I times it by itself, which is what n plus 1 times n plus 1 is over here. So I'm just showing you with examples that this works. Um, Is it okay if you get another exam question identical and go through it? Because it's very, well, to be funny, I think this is a little bit of an exception to this topic because I think it's just this end bit here is really confusing. Okay, and I think I understand that it is really confusing because it's slightly different to all of the other questions that we did. Um, so I think that makes it a little bit more challenging. So I don't think I'll see if I can find another example somewhere. But a lot of them, once you've done enough of these, like if you've done this booklet and you've got the hang of it, you're kind of ready. I'll be honest with you. There's not too many variations on this. Prove algebraically that the sums of the squares of any two consecutive even numbers, should be an S on the end of that, is always four more than a multiple of 8. Okay, again, it's wordy, isn't it? Right, as I said, let's ignore the bit after the is until later. We've got two consecutive, and you almost actually, from there, you should almost read it backwards. So two consecutive even numbers. So 2n is an even number. The even number after it is 2n plus 2, so 2 more than it. The squares of them is that. The sums of the squares is that. You add them together. So setting that up first correctly is important. And then we expand and simplify and hope for the best. So 2n all squared is 4n squared. This bracket all squared, again, if you're not sure about, because I'm doing it so fast, is write it out twice and go through that process of doing that times that, that times that, that times that, that times that, fully expand it and simplify it, and then write it down. But there is a quick way of doing this, which I'm about to demonstrate to you. It is 4n squared plus 8n plus 4. Okay, that's what that is. Then what? Right, we simplify. So the 4n squared plus the other 4n squared is 8n squared. Okay, and this one's actually quite easy. Because now that we've got here, the question, we now read the bit after the is, which I crossed out. It's always four more than a multiple of eight. Isn't that already quite clearly four more than a multiple of eight? But how do we prove it? You just take this bit and take the eight out of it. That makes this a multiple of eight, doesn't it? Because eight times something is a multiple of eight. And it is four more than a multiple of eight. And we have done the proof. So I think that was a relatively easy one if you correctly expand and simplify the brackets. That is. Right, let me see if I can find anything else. Um, can you do 19B, year 10, expanding and factorizing? Let me just show you that because I did it in the last lesson. Is that the same one that somebody else asked me a minute ago? That is 19B on the expanding and factorizing. So the only thing that's common to both of those terms, the 18M and MN, is the M. So that comes out, and then you put inside what gets you back to 18M plus MN. Okay, let me see what I've got on this proof nonsense. Oh yeah, I saw your question about rates of change. I mean, is that I don't know is the answer to that question. I don't think we specifically have that as a specific topic. Is that in maths you're doing that? Presumably you're asking me in relation to a maths topic. Rates of change and instantaneous rates of change. Just confirm that to me. I saw that answer. Sorry, I didn't reply to it. But is it, and also just confirm to me one more thing. Are you doing IGCSE as an exam board for maths? Or do you know what exam board you're doing? Oh, okay. OCR. Fine. The simple answer is not specifically, because it's not one of the maths topics that we specifically have a thing for. However, I can explain it to you in like, I don't know, I'll need 10 minutes and you'll be fine with it. So I will arrange for a time to chat through it with you. So don't worry about it. Same with anything goes. When it comes to these things, if there is something that we might not specifically get through because, we are trying to do four subjects and getting through every single, especially with maths, getting through every single maths topic is optimistic. But we will get it done. So what I can do, if you have any questions relating to it, then send them as you do. And I will find time, even if it means like one of these sessions on a Wednesday. Like we're virtually done now, right? It's 8:32. We're virtually done. I can always just do some of it in another one, not today, but in another one. I'm happy to do that. So don't worry. Yes, we can do it before Christmas or during Christmas. I mean, that's also a time I'm going to be doing nothing. Question 8, year 10. So yes, the same goes for everybody, by the way. If there is something that because just bear in mind that we have a structure which is very hard to absolutely cover absolutely every single little aspect of biology, chemistry, physics, and maths. We do, I would say, the bulk of it. And if you know everything that we teach you, you're going to do really well. So that's not a problem. But if there are specific things that you feel that haven't been done, you're not sure of, then just mention it and I will find the time to do it. Question 8, year 10. Is that the same year 10? Is that where we are? I'm really confused about who that is, because you're asking me year 10 and year 11 questions. Is that, anyway, it doesn't matter. But that's that. Um, Question 8, proof. Okay. No, proof. Okay. So, um, I'm not doing that. I decline to do that. Is it right to add a decimal instead of a fraction? Yes. I would also add one more thing, that fractions and decimals are the same thing. You know that, right? So this has the same value as this. They are the same thing. Okay, so I get this quite a lot where people say, "Can I write my answer as a fraction instead of a decimal, or decimal instead of a fraction?" Um, as long as it's correct, it is the same thing, isn't it? If the answer to a question is a half and you put 0.5 or 1 over 2, there is, I mean, you're not going to get it wrong unless the question specifically, explicitly says, write your answer as a fraction or write your answer as a decimal. They are the same thing. So that caveat is there. Um, so yes, I'm not answering this question number 8 because I don't see why you can't do that yourself, given everything that we have done so far today. An even number, you know what it looks like. A consecutive even number, you also know what it looks like. And also, to be fair, if, let me see if I can find this. I have to look at all the notes actually. Anyway, never mind. Um, so that's that done. I was going to find one more proof question. Um, oh, that's too long. Okay, I will do. And again, you might have done this one of these in the lesson anyway, but I will just do this because we haven't come across it just now. Prove algebraically that every term in the sequence n squared minus 12n plus 38 is positive. I don't know if you did this in class, but it's the requirement here was that you do something called completing the square, which I can't remember if we've done, but anyway, I'll tell you what you do now. Completing the square is when you have a bracket with a squared outside it. In this case, the letter goes there, and then you'll have some number on the outside. Now, this number gets halved and gets put into here. Then what you do is you figure out well, the whole idea of this is that this should end up being exactly the same as that, but the problem is right now it's not. If you expand this out, it is n squared minus 12n plus 36. But we didn't want 36, we wanted 38 at the end. How do you get from 36 to 38? What do you need to do? You have to add 2 to it. So if you add 2 to the end here, you will be on what you actually started with. So that is called completing the square. You may have been explained in a very slightly different way to that. Um, can you do advanced trig next week? I think I need some examples of what you mean by advanced trig. Because, um, yeah, if you have some examples of that, then I will go through those examples. How have you made it n minus 6 squared? Because that's what this is. This is called completing the square. If you haven't done it, you won't know what this is. But there is something called completing the square, which is a form of factorizing. And it comes about that, in answer to your question, the minus 6 comes about from halving this minus 12. That's the specific thing. But then what you're trying to do is change how this looks. And this is another way of making it look different. That is, just to be clear, exactly the same as n squared minus 12n plus 38. Because if you expanded out this bracket here, you'd get n squared minus 12n plus 36. And then we're adding 2 to it, which is what gives us the 38. So that is the same as that. Anyway, in answer to this question, just very quickly, the reason this proves that everything that this is always positive, again, it's quite hard to explain this, but if I have a number here and I square it, no matter what n is, n could be minus a million, but when I do minus a million, minus 6, and then square it, I am going to get a positive number. This cannot be a negative number in any way, no matter what n is. You can try it if you like. Put in n equals 5, put in n equals 3, put in n equals minus 10. No matter what happens, because you're going to be squaring it, it will end up being positive. Because if I've got a minus number and I times it by itself, the two minuses make it a positive. So the point of this is, and again, it's quite a complicated thing, is that this thing is always, well, it's greater than or equal to 0. It could be 0 if n is 6. Okay, so this n minus 6 squared must be greater than or equal to 0. It has to be. It cannot be less than 0, no matter what number I put in. And then I'm adding 2 to something, which means that n minus 6 squared plus 2 has to be, well, positive, essentially. It has to be bigger than 0, doesn't it? So um, it's definitely going to be positive. That's the point of that weird question. Question five. Have I not already done that? Oh, I haven't. No, again, is the answer to that question. Because you should just need, you should just be able to expand. If I thought I had already done this for some reason. Is it not the same question? I must have done this for someone else. I mean, is it not almost the same question as this? Number three. I mean, they're virtually the same question. I've explained how to do number three. You expand all the brackets out and simplify it. And I reckon if you do exactly the same thing to this, you're going to get almost exactly the same answer. So, no. Um, and then I was going to do, oh, this. I don't want to do this, but I might just finish with this. I think, yeah, I don't want to do this, but I'm going to. You are not going to get a question like this. I wouldn't have thought. 3D trigonometry is what you meant by advanced trigonometry. Um, so yes, I can. I'll try if you could remind me and maybe send a couple of questions through. I'll try and do it in the Wednesday session. It won't be done in the in-person lessons because you've got biology to be doing, but I can try to get some of the 3D trig. It's quite confusing. And the most confusing part about advanced trig, as you're calling it, about 3D trig, is visualizing the triangle inside the shape, which is quite hard and awkward to do. For number two, can you do use the three and do 3n instead of the six? I think you can actually. Uh, I think you'll be okay, but I just wouldn't risk it. I mean, clearly a multiple of six if you do that. But I see what you're saying. If you took three out, then you'd have 3n plus two. The only problem with that is that technically, depending on what n is, I know it can't happen, but because if n is one, then three plus two. I know it. No, you can't do that. Sorry, I'll tell you why you can't do that. Well, you shouldn't do that, and I'll just tell you why. Is that just because something is a multiple of three, which is what you're basically proving, doesn't mean it's a multiple of six, because these are multiples of three. A lot of these are not multiples of six, are they? That's not a multiple of six. That's not a multiple of six. That's not a multiple of six. If I continue to 21, that's not a multiple of six. So proving something is a multiple of three does not prove that it's a multiple of six, even though you think it probably should. It doesn't. Um, but if the question asked for multiple of 12, but this wouldn't be the answer then. If it was a multiple of 12, it would be so the answer would be something else because that isn't a multiple of 12. Because if n is 2, for example, if n was 2, 6 times 2, sorry, 2 times 6 is 12 plus 6 is 18. 18 is not a multiple of 12. So you can't prove that this is a multiple of 12. You can't because a multiple is the same point, which is a multiple of 6 isn't necessarily a multiple of 12. This is a multiple of 6, not anything else. I guess you could prove it's a multiple of 2 because every multiple of 6 is a multiple of 2. It's just a bit of a confusing one. But in this case, that's what you're supposed to do. Right, the final thing I'm going to do, because, is this question. Prove that the sum of the cubes of two consecutive odd integers. I mean, again, I don't think you would get this ever, but let's just do it and see what happens, because I don't know, because I've not done this question, so I don't know. Prove that the sum of the cubes of two consecutive odd integers. Right. Two, remember I said ignore the is always a multiple of 4 for a bit. Two consecutive odd integers. That is an odd integer. So an even number plus one. In class, we did something like using the multiple of 12 and putting out something which I don't understand. Yeah, fine. So just in answer to your question, this thing here is a multiple of 12 because if n is 1, for example, then what do we have here? We've got 6 times 1 plus 1, which is 2, 12. If n was 2, then what have we got here? We've got 6 times 2 is 12 times 2 plus 1, which is 3, which is 36. If n was 3, what happens here? We get 18 times 4. 10 times 4 is 4, which is 72. So we are getting multiples of 12 in that case. So you bringing this n out here in this particular very specific example um, is proving that you are getting multiples of 12 because you're not getting all of the multiples of 6. Do you see what I mean? Because each time you do it, you are adding 1. And so you're not actually getting, it's not like 6, 12, 18. It's 12, 36, 72. So that's essentially why that works. The best thing to do is just to put a few numbers in and see that it does work. And it does. Um, you go back to number two. Oh no, what's happened here? No, the answer to number two cannot be written as 3n n plus 1 because if you expand the brackets, I mean, that doesn't quite make, I mean, it depends on, I mean, you can't for this number two because that isn't the same as this. That's 3n squared plus 3n. So that's a completely different thing. The only thing this can factorize to is, you're asking me, yeah, this becomes 6 brackets n plus 1. You're asking me if you can take the 3 out of this, I think. And I mean, you can in the sense that it does factorize to that, no, that. But this doesn't prove that it's a multiple of 6. If there had been another n, then potentially yes. That's the point. If there's another n, then you can potentially prove additional multiples. Oh, I did do 8B of the year 10 thirds and indices booklet. Sorry, I had done that. I did that earlier. So if you, the recording of this, you'll be able to watch. I specifically did it because I went back to it. I thought you were here. You must have not been here at that point. Um, but I specifically went back and did it over here. So you'll be able to watch it back, but I can explain it to you in the lesson tomorrow if you want. Question 6 on the year 11 proof paper. I'll decide. Chances are I won't. No, I've done it. So yes, I've already done it. So you can watch that back. Um, right, I'm going to finish off with a question I've been trying to do for about 10 minutes, which is this. Prove that the sum of the cubes of two consecutive odd integers. So I told you that an odd integer is or can be 2n plus 1. That is an odd integer. A consecutive odd integer will be 2n plus 3, as in two more than the first one. They've said the cubes of them, which is annoying because it's going to take forever to expand this, but I will do it quite fast for you. Um, okay, the sum of the cubes means you add them together and cube them. Now we need to end up with a multiple of 4, but we'll deal with that much later. I need to correctly expand these. To expand a cubed bracket, this is what I would do. I would write the bracket squared and then another one because that makes it cubed, but it makes it easier because I'm going to have to do this two brackets and then the third one. If that makes sense. Similarly here, I'm going to do two brackets, so square it, and then do the third one like that. So let's do this. I'm going to do it again. I'm going to do it quite fast, and I appreciate that that isn't fantastically helpful. But um, if you expand the 2n plus 1 squared, it is 4n squared plus 4n plus 1. And we're going to times that by the other bracket in a moment, but I'll do this at the same time. 2n plus 3 squared is 4n squared plus 12n plus 9. And it's going to multiply by the 2n plus 3. So we now go back to this. And remember, when you're doing this now, each term in the first bracket needs to times by every term in the second bracket. So there's quite a lot to do. 4n squared times 2n is 8n cubed. 4n squared times 1 is 4n squared. 4n times 2n is 8n squared. 4n times 1 is 4n. 1 times 2n is 2n. And 1 times 1 is 1. Let's simplify this. 4n squared plus 8n squared is 12n squared. 4n plus 2n is 6n plus 1. Okay, move on to this one. 4n squared, let's draw a line here. 4n squared times 2n is 8n cubed. 4n squared times 3 is 12n squared. Move on. 12n times 2n is 24n squared. 12n times 3 is 36n. 9 times 2n is 18n, and 9 times 3 is 27. Wow. Okay. And then let's simplify that to 8n cubed. 12n squared plus 24n squared is 36n squared. 36 add 18 is 54 plus 27. Okay. Again, this is not realistic for your difficulty level. Well, it's not even that difficult. It's just long. But also, you tend not to get questions that are really long because there's a limit to how much time you have in an exam, and they don't want to give you half an hour doing one question because that would be inefficient. So that's why it's unrealistic. 8n cubed plus 8n cubed is 16n cubed. 12n squared plus 36 is 48n squared. 6n plus 54n is 60n. Oh no, got a problem. No, I haven't. I'm good. 1 plus 27 is 28. So we've simplified it all down to this. And we need to show that this is a multiple of 4. And because I've done it correctly, all of these numbers are multiples of 4. So I can take 4 out and leave myself with 4n cubed. That's 6 plus, oh, sorry, there's an n there. 12n squared, 15n plus 7. That has proved that this is a multiple of 4 because the whole thing ends up being a multiple of 4. Don't worry about that one. Just a bit of entertainment at the end. Right, I think that's it. Next week, I think in the lessons, depending on what day your lesson is, we are doing some digestion over the next week with year 10 stuff, and year 11 are doing the second part of genetics, which includes things like evolution and selective breeding and classification and genetic engineering. Quite a lot of stuff because you did one part of genetics last month. We will also try and do some of that 3D Pythagoras and trig that someone has requested. But that's all. I will see you